ரெக்கார்டிங் பண்ணிருக்கேன். பலமது பண்ணிருக்கேன். இல்லை மேடம், வெளியில் மேடம் இப்போ தான் மேட் பண்ணுறேன். மீட்டில் we can start now. Yes, ma'am. Very good afternoon to everyone. Hope I am audible to all of you. Yes, thank you, ma'am. Most respected Vice Chancellor of Periyar Maniam Institute of Science and Technology, and the most respected Registrar ma'am, and the convener of this 6 days international workshop, Dr. Magesh, Head the Department of Software Engineering, Periyar Maniam Institute of Science and Technology, and coordinator of this workshop, Dr. Anusa and Dr. Saranya from the Department of Software Engineering of PMIST, and the participants from various parts of Tamil Nadu and outside of Tamil Nadu and other countries as well. So very good afternoon to everyone. It's a matter of honor and privilege for me to be with all of you in this afternoons to deliver the invited talk as part of the 6-day international workshop on AI for Educator, organized by the Department of Software Engineering of Periyar Maniamma Institute of Science and Technology. So I would like to extend my thanks to the convener of this program for providing me an opportunity to discuss about the various challenges and the kind of opportunities that are available in the area of artificial intelligence and machine learning research. So when you see the today agenda of my particular presentations, I am focused more on explaining the conceptual view of artificial intelligence, followed by what are all the research challenges and opportunities available in the area of artificial intelligence. Then I'm going to talk something about the concept of machine learning, followed by what are the various research challenges and opportunities available in the area of machine learning. Then I'm going to talk something about what are all the technology use cases available in the era of both artificial intelligence and machine learning related to two different kind of experiment I am really interested to discuss with you. The first experiment is about the kind of social experiment to illustrate the people behavior, which is part of the behavioral analytics, is one of the emerging and booming technology as in the field of artificial intelligence and machine learning. And my second use case will be focused more on how to deploy the kind of machine learning algorithm for employee attrition predictions, where I'm going to discuss about how to apply the kind of ML stuff on both the primary and the kind of secondary data that collected from the real world. Then I am much interested to explain about what are all the technology and reality we faced during the pandemic of COVID-19 that I'm going to tell about some real world story with for you. And finally, I'm going to talk about something on what is the responsible artificial intelligence and what are the challenges and difficulties when we work with the kind of various AI systems, followed by the summary of my presentation. And finally, I come to the conclusions. So this is the overall agenda of my today presentations. And hope most of you are aware of what is the underlying mechanism of both artificial intelligence and machine learning. So I'm not focused more on explaining what are all the technological stuff offered by the both artificial intelligence and machine learning. So instead, I'm interested to explain about what are all the different skill that I pursued during my course of doctoral program between the year 2004 and 2009, when I associated with Anna University Chennai as a research scholar, where I pursued my research in the area of machine learning and data science research. And I'm also interested to discuss with you about my personal experience on what are the kind of experience that I pursued after my doctoral research, that is both post-doctoral experience that I am going to discuss and elaborate a little bit. So where I focus on what are the different kind of machine learning algorithm and model I really interested on, and what are the different ML stuff that I propose, and what are the different theoretical contribution that I done as part of the data mining and machine learning research. That is the overall agenda of my today presentations. Anyhow, I am little bit interested to explain about the conceptual view of both artificial intelligence and machine learning. Then later I will come to explain about what are all the experience that I perceived during the course of my PhD as well as the post-PhD studies. So hope most of you are aware of the history of artificial intelligence, which was really evolved between the year 1970 and the year 1990. So even when I handled the subject of artificial intelligence in the year 2003, after my after receiving my master degree, so I worked with Tyagaraja College of Engineering, Madurai, where I got an opportunity to take the subject that is called as artificial intelligence. So when you compare the conventional kind of AI stuff with the current AI, you can see the lot of differences among the conventional and current artificial intelligence technology. Say like the conventional kind of AI is said to be the narrow artificial intelligence or old AI. The current AI is said to be the hard or is a kind of new AI or is kind of said to be the super artificial intelligence. So that is the kind of difference between the conventional and the kind of new artificial intelligence. When you see the year between 1990 and between 1990 to the year 2010, the people are much interested about applying the various statistical algorithms in order to make the kind of prediction or any data classification task. So, so most of the medical research, they really interested to apply the kind of statistical model to evaluate the performance of various data mining and machine learning algorithm and to evaluate the efficacy of the various drug that related to the healthcare research. And when you see the history after 2012, the people are talk about the big data. Big data was evolved in the IT industry. The people are talk about the kind of R programming and Python stuff and big data, deep learning, machine learning, so on. So after 2012, the AI is almost used in many industries, starting from academia, healthcare, agriculture, so on. So when we talk about what is artificial intelligence, personally, I believe that there are four different kind of capabilities that applicable to any kind of artificial intelligence system. The first capability is called as think humanly, and the second capability is called as think rationally, and third capability is called as act humanly, and the finally that is called as act rationally. So, but when you see the current artificial intelligence system, the current AI is not able to fulfill all the four capability that applicable to any kind of artificial intelligence. Say like when we consider as in the case of GPT. So what is the real benefit of GPT over the conventional kind of AI stuff is the GPT can able to remember what you said earlier during our conversations. So that is a kind of act rationally and act humanly. So now there is a question for you. Say for example, how do you make the kind of rational decisions in the real world? As in the case of the machine, I think it's very difficult because as a human being, we have to apply our common sense, affection, love, heuristic, so on, so in order to make the kind of rational decision making. But when you consider the same scenario to the machine, sometimes I personally say the machine is a kind of stupid things. We cannot compare the human being with the machine because human being possess lot of capability like creativity, common sense, love, affection, so on, so. But there are when you see the current capability offered by the artificial intelligence, the people are talking about another major thrust area of artificial intelligence that is called as cognitive artificial intelligence, which try to mimic the behavior of the biological brain. Is something like how the human biological brain or behave and how to model the behavior of the biological brain. That is another most thrust area as in the case of artificial intelligence that is called as cognitive artificial intelligence, where the people try to apply the different kind of stuff, say like heuristic algorithm people try to apply and people try to apply the kind of optimization algorithm, say like ASP and TOPSIS. These are the kind of optimization algorithm are available to make the kind of rational decisions in any kind of machine rather than the human being. So hope most of you are aware of how to define the kind of artificial intelligence and machine learning. So I say the artificial intelligence is a study of how to make the computer to think in which at the moment the people are better. Otherwise, we say the artificial intelligence is a kind of developing the intelligent machine which behave the similar to the human being. So there are a lot of definition are available to define what is artificial intelligence, but there is a very good definition given by the John McCarthy. He defined the artificial intelligence is a science and engineering of developing the kind of intelligent machine, especially the intelligent program that is basically called as the artificial intelligence. So uh, when we compare the three different stuff, namely artificial intelligence and machine learning and deep learning, so we can always see the kind of overlap between AI, machine learning and deep learning areas. But the point is we cannot interchange AI with the deep learning or AI with machine learning or deep learning with the machine learning, we cannot able to do the kind of interchange among these different technology. But now the question comes, what is the major difference between AI, machine learning and deep learning? So when we talk about the artificial intelligence, it's a kind of developing the intelligent machine which behave or which mimic the human intelligence. That is what the basically the artificial intelligence. But the machine learning, the people say the machine learning is a subset of artificial intelligence where we try to make use of the training data where we apply the different machine learning algorithm. The algorithm are learned from the training data and algorithm are capable to generate the model. Now we test the model with the help of test data, and then if the performance of the model is satisfactory, we deploy the model to the different user. Now there is a question: what is the real what is the real thing or real element that is required to execute any kind of machine learning algorithm? Is training data is very, very essential for working with any kind of machine learning algorithm. Assume that if you are not provide any kind of training data, we cannot able to apply the kind of machine learning algorithms. So data or the training data or the historical data is a very, very required fundamental element if you want to do any kind of machine learning algorithm, or if you want to develop any kind of model using machine learning, the training data is very, very essential. So now coming to the point of deep learning, the deep learning is basically defined as the subset of artificial intelligence where the AI is said to be the mother and both machine learning and the kind of deep learning are said to be the child of the artificial intelligence. So when we compare the both machine learning and the kind of deep learning stuff, basically the deep learning is basically derived from the concept of artificial neural network. Even when I studied the artificial intelligence during the year 2003, so it's focused more on the kind of perception learning and path propagation neural network. But when you see the current deep learning algorithm, we can talk about the various different kind of deep learning algorithm, particularly GAN, that is called as generative adversarial neural network. That is a kind of most popular deep learning algorithm used in many kind of different vertical domains nowadays. Say, for example, if it is a kind of image processing applications, or if it is a kind of natural language processing application, or if it is a kind of voice recognition system, or if it is a kind of gaming application, the people are almost try to apply the kind of GAN architecture. Now there is a question comes, why GAN, why not other kind of deep learning algorithm? Because there are two different kind of capability offered by the particular deep learning algorithm, or particularly by the GAN, or the GAN algorithm are really capable to generate its own image that is called as a kind of artificial or synthetic image. Then we have to compare the both synthetic image and the real world image where we apply the different GAN algorithm. The algorithm are capable to make the very accurate kind of prediction if it is the case of most of the image processing application. Even very recently, I applied the kind of GAN model for the application that related to the healthcare, because when you see the literature of the deep learning, the literature says the kind of GAN algorithms always provide a better result if you work with the kind of agriculture applications. So comparing with the machine learning and the deep learning, there are a lot of capabilities offered by the deep learning. The first capability is called as when you see the kind of deep learning algorithm, obviously the performance is very complex because the deep learning algorithm inherit the property from the artificial neural network. So which really consists of so many number of multiple layer of network. Otherwise, I say the so many number of neural network. So that is obviously there are a lot of computational complexity that is offered by the kind of deep learning algorithm. But when you compare with the deep learning and kind of machine learning algorithm, there is one of the limitation of deep learning algorithm is the deep learning is again the kind of black box method. So we cannot able to make the kind of very good interpretation if you work the kind of deep learning algorithm. But when you work with a kind of machine learning model like decision tree or the kind of logistic regression, we can able to easily interpret what is derived while applying the various kind of machine learning algorithm. So obviously there are a lot of computational complexities are really associated with the deep learning algorithm comparing with the machine learning. But when you see the performance of both the DL and machine learning, obviously the performance is very good for the deep learning algorithm comparing with the various kind of machine learning algorithm. But when you see the scope of both machine learning and the kind of deep learning, most of the data science application and most of the text mining application, the people are using the kind of machine learning stuff. But as in the case of the image processing application or kind of voice recognition system or any kind of natural processing language application, the people are really interested to apply the deep learning algorithm over the kind of machine learning stuff. So coming to the basic classification of the various kind of artificial intelligence system, basically there are three major type of AI. The first category is called as the weak AI, and type 2 is called as strong artificial intelligence, and the type 3 is called as artificial super intelligence. So whatever the technology that we are working nowadays are said to be the kind of example for the weak AI. Say like if you are doing the kind of data classification problem, or if you are doing the kind of prediction application, or if you are doing the kind of attribute selection or feature selection algorithm, where you try to select the relevant feature for your data mining or the machine learning task. These are the kind of example for the world artificial intelligence or narrow artificial intelligence applications. When we talk about the second type of AI is called as a strong AI. So where it is really expected that the machine which mimic similar to the human intelligence. Say like we know we are capable to uh, work with various kind of cognitive skill. Say for example, we are really good to compose any kind of poem, or we are really good to compose any song, or we are really good to create any kind of what I say is a paint or any kind of art. We are really capable. So these kind of skill are said to be the kind of creativity or kind of natural skill. But if you able to create those kind of skill to the machine, that is said to be the kind of strong artificial intelligence. But developing those kind of system is really very, very challenging, because mimic the behavior of the human intelligence is very, very complex stuff. So where is really need to work with the kind of cognitive research. But when you see the history of artificial intelligence, again, the cognitive research is not evolved fully. There are a lot of research are going on in one of the leading universities in US, that is called as Stanford University. So they are working on cognitive artificial intelligence. And that type of artificial intelligence is said to be the artificial super intelligence, where it is really expected to develop the kind of machine which are really capable or which are really better than the kind of human being. But I think it's very really difficult to develop the kind of super intelligent or to possess the kind of super intelligent to any kind of machine is very, very complex task, because which really involve where we need to provide the four different capability of artificial intelligence. Even during my previous presentation, I talked about the current AI. When you see the current artificial intelligence, they are not really capable to fulfill all the four capabilities that are offered by any kind of artificial intelligence systems. So again, when you see the difference between the machine learning algorithm and the deep learning does not require the human programmer to tell them what to do with the data. So because the deep learning algorithm are really capable to perform the automatic feature selection, which really not case for the machine learning algorithm. Even when you work with any kind of machine learning algorithm, what we are supposed to do is we have to apply the variety of attribute selection method for the initial the training data, where we try to identify what are all the relevant feature related to our task, where we have to apply the different kind of attribute selection method or attribute selection algorithm. That is not really case as in the case of deep learning. And finally, one of the major difference between the kind of machine learning and deep learning is that deep learning are really capable of performing the self-learning that is not possible for the machine learning algorithm. So which is similar to the human intelligence. Assume that I am the kind of person, I am getting the very poor performance in my examination. Say, for example, assume that myself as a student and I am appearing for the examinations and I am receiving the very low grade. So what I am supposed to do as a human being, I have to iterate my behavior, or I will try to iterate my intelligence in the different way, or otherwise I do the kind of self plan, apply my self planning capability. So what will happen in the later stage is my performances get improved, but that is the not case as in the case of the conventional machine learning algorithms. So that is the main advantage of the deep learning algorithm comparing with the machine learning model is that it support the kind of self-learning capability that is not possible with any kind of machine learning algorithms. So coming to the point of what kind of personal experience that I gathered during my research and postdoctoral period, even between the year 2003 to the 2009, my research was focused on the kind of developing the kind of various intelligence system as in the case of the machine learning and deep learning applications. So when I started my career in the year 2003 at Tyagaraja College of Engineering, Madurai, where I focused more on developing kind of the cyber security application by applying the various machine learning and data mining stuff. But when you see the tragedy of September 11, 2001 in United States of America, which may lead to the permanent effect to US and the rest of the entire world. So when you see the World Trade Center attack in the year 2001, the source says there is an exchange of information between the different terrorist community with the help of kind of email communications. So what happened in the year 2003 is the CBI and FBI and other federal agencies are really failed to identify what are the possible meaning of the kind of information that are exchanged between the different terrorist communities. But there is a question happened in the year 2001, like how many terrorists will send the email like today there will be a bomb blast in the parliament house. If they do so, they will probably use some kind of information handling techniques. So what happened in the machine learning algorithm are they are not able to identify the meaning of coded words that are exchanged between the different terrorist communities. But when you see the history, most the realistic terrorist email is something like some known agent X will send the target Y to the destination Z. But the actual meaning is something like some known agent Al Qaeda will send the bomb to the destination airport. But what is the major problem associated with any machine learning or data analytics stuff is very difficult to identify the meaning of the coded word that are exchanged between the different terrorist community, which again really challenging task. So what is really required in that case is so we need to develop the kind of interdisciplinary and multidisciplinary research where we need to combine the two different kind of technology. One side we have the data science and machine learning. Other side we have to integrate the kind of information security or network security or cyber security application that is really very, very essential. Even 2003, we have submitted one project proposal to DRDO. That time we combined the different capability that offered by the both machine learning algorithm and the kind of cyber security in order to handle this particular problem in the effective way. So coming to the history of the machine learning, much of what we know in physical sciences had their origin in astronomy with the observation of celestial objects. Thanks to Herculean effort of pioneers, thanks to Galileo, thanks to Newton, thanks to Kepler, these are all known among other in the field of physical sciences. It is also observed that the law of gravitation by the Newtons, the four law of the Kepler, and law of gravitation by the Newtons and Newton law, these are said to be the some of the earliest example of machine learning or the data analytic stuff. So now coming to the question, what is the machine learning is kind of extracting structure or pattern from the large volume of data. So when you see the history of machine learning, the most of the celestial object inherently follow certain law. So early pioneer with the hard work and ingenuity would lead to the development of the physical sciences and engineering sciences as we know today. So it is estimated that the volume of data collected double in every 3 years. The volume of data collected double in every 3 years. Thanks to computer, thanks to larger scale storage devices, and also thanks to the sensor technology. When you see the today interest of data machine learning, the today interests include all the physical sciences, biological sciences, engineering sciences, medicine, and government at all levels. The newly formed the Newton's law, along with the concurrent development in calculus and statistical theory, would lead to the development of the dynamic model. So, which very clear and which are really helpful if we want to make any kind of prediction or forecasting or any kind of data classification, as in the case of machine learning models. So, most of you know about the Gauss when he was only the 24 years old. Using the known model of his time, he taken up the very challenging problem of predicting the celestial object that called as a Cirrus with the help of the instrument that is called as a telescope. By identifying the celestial object, he is capable to develop the another terminology that is the most popular, as in the case of the statistical theory, that is called as method of least square. So, which is one of the most widely used method, as in the case of evaluating the performance of any kind of unsupervised learning algorithm, or particularly as in the case of the clustering model. We are using the method of least square as one of the benchmark performance evaluation metrics. So when you see my research area, I focus more on how to develop the performance of the different machine learning algorithm. I focus more on how to deal the kind of exception that arise in the various machine learning algorithm. Particularly during my the course of PhD, I focus more on how to improve the performance of various classification algorithm. That time I interested on the three different classifier, namely the decision tree, Bayesian classifier, and finally k nearest neighbor. And I also interested on another area that is called as the feature selection, where as part of my doctoral research, I developed a variety of vertical feature selection method with the help of various ranking and re-ranking, clustering, and unsupervised kind of clustering algorithm, etc., etc. So the people always assume that the machine learning is a kind of interactive process. But I personally says the machine learning is a kind of both iterative and the kind of interactive process, where the algorithm is really interested to develop the kind of machine learning model. But when you see the any data analytics industry, 90% of the time and effort is only spent towards the data cleaning process, because there is no quality data and there is no quality research. This is because the quality of the result is fully depends on the quality of the data set that used for the experimentations. Even during the year 2009, so I received one grant from the UGC University Grant Commission when I worked with Tyagaraja College of Engineering, where I focused more on how to deploy the kind of data quality checking algorithm, where I collected the data from the UCI repository and apply the various data mining algorithm. Later, I found that the performance of the data mining algorithm is really degraded while learning from the kind of noisy data. But previously, I assumed that the performance are only degraded due to the quality of the data mining or machine learning algorithm used for the experimentation. But after executing the experiment only, I came to know that the performance is not only degraded by the nature of the data mining or machine learning algorithm, is also degraded while any machine learning algorithm is learning from the kind of very sensitive or the noisy data. So where I interested on two different kind of data. The first kind of data is said to be redundant data, and the second kind of data is said to be the conflicting data. So most of you aware of what is the redundant data. Redundant means when you see the same kind of values in both predictor and the class label in machine learning data set, that is called as redundant data. But when you see the same kind of values in the predictor, but the kind of different values in the class label, those kind of record is said to be the kind of conflicting data. So what will happen if you apply the various machine learning algorithm on the conflicting data, the performance is get degraded. Particularly if you apply the kind of KNN algorithm, this KNN algorithm is very sensitive to the noisy data. KNN is very sensitive, but the algorithm like Bayesian is very less sensitive to the noisy data, and the algorithm like SVM is average sensitive to the noisy data. I think it's a very good kind of theoretical research in machine learning. Because when you see the various kind of research that are executed in the area of machine learning, most of the researchers are really interested on the apply research, where they try to apply the different machine learning stuff on the various kind of applications. Say like they try to apply the machine learning on healthcare data or agriculture data or data for the financial domain or data from healthcare or agriculture or educational system and so on. But what is really required now is you focus more on the theoretical research as well, because there are a lot of scope for theoretical research rather than the application research. Even when you see my research area, I focus more on, previously I focus more on the kind of theoretical research where I develop the different a kind of exception in the conventional machine learning algorithm, particularly the decision tree and Bayesian and the kind of KNN methods. Now, what are the mathematical skill required for the machine learning or understanding of linear theory, understanding of nonlinear transformation, understanding of the vector metrics, and understanding of calculus, understanding of probability statistics. These are the very essential skill required if you want to do the kind of stuff for application using machine learning and data science. And when you see the kind of technique for the machine learning, there are basically two major classifications. The first type is called as classification, and another category is said to be the predictions. And so people know about what is the attribute selection. That is another more very essential research areas in the case of the machine learning. As in the case of the biological domains, this attribute selection is very important, because when you see the data from the kind of biological domain, which consists of million to billion of column, where if you apply any kind of machine learning algorithm on million to million of column, the data set with million to million of column, what will happen is the performance of your algorithm is get degraded. That is why we try to identify what are all the relevant attributes related to my task, and what are the algorithm are irrelevant. Those attributes are to be removed before going to apply any machine learning algorithm. So these are the various kind of capabilities offered by this any kind of attribute selection method. The firstly is obviously reduce the number of initial attribute, and is always reduce the computational time to take to develop any kind of machine learning model, and obviously is improve the performance of any machine learning model. Say like if you are applying the machine learning algorithm on the original data set, and you are applying the same algorithm on reduced data set, obviously the you can able to see the very good performance on the reduced data set. So what is really required is it is possible to develop the kind of attribute selection method or feature selection algorithm where you test those algorithms with the help of the data from biological domain. So where there is one of the benchmark data repository that is available is called as Henrich Biomedical Data Repository. So what is the specialty of this particular repository is, which consists of many number of columns and minimal number of rows, where it is really possible to work out with kind of different kind of attribute selection or feature selection algorithms. And these are all the various major challenges, as in the case of any machine learning and data science research. The first challenges is called as the data size challenges, because we know the size of the data grows similar to the more law of central processing unit speed, or it grow more than the linear, and data complexities that also get increased. This is because the different type of data is available, and the dimensionality of the data get increases, and the curse of dimensionality affect many machine learning algorithms. Say like particularly as in the case of the KNN classifier. So what is the major problem in the KNN classifier is to identify the number of K that required for the given test record. Assume that you are working with a million or billion of records with a minimal number of row, where you provided with a kind of test record and you are really interested to find out the appropriate class label for the given test record. What you are supposed to do is, for the given test record, you try to compare with the million of training data, where obviously it's very difficult to identify who are all the nearest neighbor for the given test data. If when you work with the million or billion of training data, the task is very, very complex. This is said to be the kind of curse of dimensionality. So when you work with the kind of KNN algorithm, obviously it's very difficult to fix what is the recommended or what is the appropriate K values. So there is no method is available in the machine learning literature which tell about what is the optimal K values before going to apply any kind of machine learning research. There is no method available in the literature. So I would request to all the scholar, those who are working in the area of machine learning, you try to develop the kind of mathematical model where you try to get the different kind of input from the data and try to develop or derive a mathematical model, and where it is expected that your mathematical model are capable to identify what is the appropriate K value for the given data set before going to apply any kind of machine learning algorithm. I think it's a very good kind of theoretical research expected as in the case of KNN algorithm. Even when you see my research, when I pursued my PhD, I handle this kind of problem in the KNN algorithm. I propose a kind of approach where I focus more on how to identify the appropriate K value for the given data set before going to apply the machine learning algorithm on the collected data. That is the point that I discussed as part of my doctoral research as well. And finally, the data quality, that also another challenging problem, because the real world data are always messy and dirty, and mostly the noise comes from measuring instrument. So that is why understanding of the power of measuring instrument, that also very, very essential if you want to work with any kind of machine learning or data science research. So another major problem in the machine learning area is machine learning yesterday to machine learning today. So when you see 100 years ago, you can see only one class. But when you see 50 years ago, we can see the two different classes. But now there we can able to see 3 or n number of classes. Say for example, when you see 100 years ago, one symptom may be associated with only one disease. But 50 years ago, same one symptom may be associated with more than one disease. But now, the same one symptom may be associated with n number of disease. Say for example, body pain that may be associated with n number of diseases, say like fever, COVID-19, and kind of dengue disease, so on. So what is the major problem here is one symptom or one predictor may be associated with n number of classes. That is said to be the kind of multiple or the kind of multi-label classification. So what is the major problem here is one record that may belong to more than one classes. So what will happen in this particular case is, assume that you are applying your machine learning algorithm on those kind of data set. What will happen is your algorithm is not able to make the kind of prediction or not able to make the kind of classification or decisions. So what will happen is you may face the problem of tie breaking. That means the algorithm are not capable to make the kind of appropriate or the kind of rational decision. So this is kind of problem is called the problem of tie breaking in machine learning algorithm. So what is really required is you try to develop the kind of theoretical data mining or machine learning model. It is expected that those algorithms are really capable to handle the problem of where one predictor that may be associated with more than one classes. Even during my course of postdoctoral research at IIT Roorkee, I was really interested to develop the kind of new machine learning algorithm or the kind of new classification algorithm. I named that particular algorithm as AVD, that is called as attribute value dependent classifier. So in which I really interested to, instead of looking at the various kind of predictor attribute along with the class label, I really interested to look at what are all the various value offered to the each attribute values, and those values are compared with the various kind of the class label. So when you compare with my developed AVD classifier with the kind of all the conventional classifier, I focus more on how to interconnect both attribute values and the target variable. That is not really case as in the case of most of the conventional kind of machine learning algorithm. Even I also proved the efficacy of my proposed AVD classifier, and I found that my algorithm are really capable to provide the better result in many cases, but not in all the cases. And I also found that this AVD are comparatively better than the conventional machine learning algorithms, namely decision tree, Bayesian classifier, and KNN and artificial intelligence as well. So what I am requesting for the new researcher, those who are pursuing or PhD in the machine learning, you try to develop the kind of new machine learning algorithm, so which are capable to look at the interlink between the attribute values and the target variable, and compare with the kind of other conventional classifier model, and try to prove the efficacy of your model. There is a chance of getting very good publications. Because when you see the publication point of view, theoretical research attract more positive response from most of the publishers. Even during the course of my PhD, I developed the three different improved version of the decision tree induction algorithm that I explained during my next slide. And when you see what are the challenges and opportunity that are provided by the machine learning and data science, is one framework with many variation is really very, very important. Even more, even the people are often getting confusion that, sir, say like I'm working on the particular project, whether I need to stick on with any particular machine learning algorithm, or I need to apply the variety of machine learning algorithm for the given problem. But my personal point is that instead of focusing and applying any individual model on your data, you try to apply the variety of vertical machine learning algorithm on your data set and try to evaluate what about the performance of the algorithm on the chosen data set. So this is because there is no catalog is available in the machine learning research to explain to you which algorithm will provide the better result for the given data set. So what is really required is you try to apply the variety of algorithm on the data set and then evaluate what will be the performance of the each algorithm, and finally you have to pick the most performing algorithm. That is the point. The point is there is no catalog is available in the machine learning research which will explain to you which algorithm will provide the better result for the given data set. And the second point is that you try to understand the power of each algorithm. That is very, very important. So what is really required is, before going to apply any kind of machine learning algorithm on the collected data, you try to do the kind of theoretical survey, or you have to do the kind of analysis on what are all the power offered by the each and every machine learning algorithm, rather than randomly pick any algorithm and apply to the any kind of data set is not really the rational way of applying the machine learning algorithm for the given data set. So what is my point is that you try to understand the power of each and every machine learning algorithm if you are doing any kind of research on the machine learning. The third point is that try to solve everything mathematically. That is very, very important. And also the cross culture, that also the fundamental tool to promote any kind of machine learning research. Say like if you are the kind of machine learning researcher, you go and meet the doctor, otherwise you go and meet the policeman, or you go and meet the people of electrical engineer, or you meet the electronics guys, because they are generating the data related to the sensor technologies and other area. And also the doctor are generating the data related to the healthcare. So this is why the data science and machine learning is a kind of cross culture where you need to interact with the different people and try to formulate the problem accordingly. And this is the kind of major research area that available in the machine learning and artificial intelligence. firstly the medical diagnosis and precision agriculture, and development of new machine learning model. Say like precision agriculture, even I worked in this particular area, and also I received the grant from ICSSR in the year 2018, where I applied the different kind of AI and ML stuff. I apply the different kind of sense technology, and I also perform the kind of primary data analysis where I met the different farmer in the agriculture area, and I make the kind of interaction with the various farmer, and I applied both kind of machine learning and data analytics stuff. So that particular project is supported by ICSSR. Even when you look at the major funding agency nowadays, they are giving most priority, as in the case of agriculture research. Those who are pursuing your PhD in the area of machine learning, better you focus more on how to apply the different machine learning stuff, as well as the deep learning stuff in the area of agriculture. Even during my previous discussion, I mentioned that if you want to work with agriculture data or agriculture image, better you work on kind of GAN algorithms. GAN algorithm. I hope this particular algorithm definitely provide better result for most of the images. Because what is the problem? Major problem in the agriculture data set, sometimes the data is not visible, or data may be very sensitive, but this particular GAN algorithm are really capable to learn from noisy image or very sensitive image. That is the kind of capability that offered by this GAN algorithm, right? So you guys, if you are working with the kind of agriculture research, you apply the various kind of deep learning algorithm like ANN or kind of RNN or kind of GAN algorithm. I definitely say GAN algorithm may provide the better result for the most of the cases. And the third, you focus more on develop the kind of new machine learning model that also very easy to attract most of the publisher. And you do the kind of sensitivity analysis, that also another major research areas in the case of the machine learning. So what is really required in that case, you have to collect the data from various sources, and where you apply the different machine learning algorithm, and then you evaluate how well the performance of the model are affected by while the algorithm are learning from various kind of sensitive information. Then another interesting area is called as larger the data, lesser the error. Say for example, if the data size is large, the error is very less, as in the case of the machine learning algorithm. Similarly, if the data size is small, but the error is high, you do the kind of empirical research where you collect the data of small scale and large scale, then you apply the various machine learning algorithm and then evaluate how well the performance of each machine learning model are affected by both small and large data set. And you can do the kind of time series analysis that is very interesting, where the people are applying the different machine learning stuff. Particularly, I think ARIMA is a most of the popular algorithm, as in the case of time series analysis. Even when I pursued my master's degree at IIM Trichy, so I worked with the kind of business analytics application where I focus more on applying this kind of ARIMA model, as in the case of time series data for many of the business applications. So my point is that if you are doing the business analytics or any kind of research as in the area of marketing, so I recommend you to work with a kind of ARIMA model, that is one of the most powerful time series model as in the case of business research. And another major interesting part in the theoretical research is the k-mean clustering. So again, there is a hope most of you are aware of what is the major problem associated with the k-mean clustering is way of the k selections. That is always challenging problem. But till there is no method is available in the machine learning research to pick the appropriate value for the k before going to apply any kind of unsupervised learning method. And again, the way of k selection in the KNN algorithm, no theoretical framework is available in the machine learning research. Guys, if you are interested in the kind of theoretical research, either you try to develop the kind of mathematical model for both KNN, how to identify the k value for the k-mean clustering, or you focus more on how to identify the appropriate k value for the KNN classifier. There are two different areas that you may work in these particular examples. And again, the weather forecasting system, you can apply the kind of clustering and classification algorithm. Again, there are a lot of scope for the data quality checking because there is no quality data and there is no quality research. I think the data quality checking alone is a kind of very good research, as in the case of machine learning areas. So what I'm suggesting you try to develop the kind of data quality checking method or algorithm, and you try to do the kind of primary data analysis, if possible the secondary data as well, and you try to evaluate the performance of various data mining or machine learning algorithm, how the performance is get degraded while learning from the kind of various sensitive data or various data with outlier. That is a very, very important part. And finally, there are a lot of scope and opportunity for attribute selection or feature selection algorithm if you work with any kind of machine learning algorithm. But as in the case of the deep learning, there is no feature selection is required, because the deep learning algorithm are really capable of pick the feature in the automatic way. That is a kind of self-learning capability or autonomous capability that offered by any kind of deep learning algorithms. So when we talk about the type of various kind of machine learning algorithm, basically there are three major categories, that is the supervised, and second category is unsupervised, and finally is a kind of reinforcement learning. And hope most of you are aware of what is the difference between the supervised and unsupervised learning. So supervised learning, most of the time the value of the class label or the target values are provided to the user. But as in the case of the unsupervised, we are performing the learning without the target values or without the help of the teacher. And so when you see the major category of classification algorithm, basically there are 6 traditional kind of classification algorithm. Firstly, there is a kind of decision tree. The second category is a Bayesian. The third is KNN. Then we have artificial neural network. Then we have support vector machine. Then we have other all kind of hybrid or any kind of what is it, kind ADA boost or gradient boost or kind of hybrid machine learning algorithms. Even when you see that during my course of PhD, I focus more on 3 different kind of machine learning algorithm. The firstly, the decision tree, and the second is the Bayesian, and third one I focus more on the kind of KNN algorithms. So hope most of you are aware of what is the history behind the decision tree. Even hope most of you are aware of the decision tree. The very basic kind of algorithm is called as ID3. That algorithm was introduced in the year 1979 by one of the leading professor in Australia at one of the leading university, that is called as University of Sydney. The name of the author is Quinlan's. He proposed a kind of ID3 algorithm in the year 1979. But the major problem in the ID3 algorithm is capable to handle only the categorical attribute, but they are not capable to handle the kind of the attribute of numeric type. So that is why after year 1999, particularly between 80 to 81, the another incremental version of the decision tree algorithm was introduced by the same author, that is called as C4.5, otherwise is called as J48 in Vega. In Vega, that is called referred as the J48 algorithm. So I am very proud to share with you that so we are the only Indian author, myself and my supervisor, actually Dr. S. Rajaram, and he's a former professor of Tyagaraja College of Engineering. Now he is no more. And some along with other 2 students from Tyagaraja College of Engineering, and 2 guys are working in University of Sydney at present. We developed the kind of incremental version of the decision tree induction algorithm. We named this algorithm as ID6NB algorithm. So I happy to share that this algorithm is available in Wikipedia and also listed as one of the most significant and major contributed algorithm, as in the case of the machine learning research, and also cited as one of the kind of incremental version of the decision tree induction algorithm in the year 2009. So the point is, if anyone interested to work with decision tree induction algorithm, and if you are really interested on performing the kind of theoretical research in decision tree, better you go to the website of this particular part and you just download my paper ID6NB and try to develop this particular algorithm in the further way. And this particular idea is also accepted and published in one of the reputed journals, that is called as knowledge-based system elsewhere, with the impact factor of nearly 9 in the year 2009. So what is the problem I face in this particular algorithm? This is a paper where you can see the kind of contribution that I done as part of this decision tree index algorithm. So the title of that particular paper is Knowledge-Based System for Text Classification using ID6 and B algorithms. So what are the different contributions that I done as part of this algorithm is, hope most of you familiar about what are the problems that associated with the kind of decision tree index algorithm. One of the major problem is called as majority voting failure. I think this is the one of the terminating condition of any decision tree induction algorithm is called as the majority voting failure. But none of the procedure is available in the data mining or machine learning research, which explain what will happen if the particular data set possesses the problem of the majority voting failure. So there is no solution is available in the machine learning research to handle the kind of this particular problem. So as part of my PhD research, I have provided the kind of solution to handle the problem of majority voting in the conventional decision tree induction algorithm, where I make use of the kind of naive classifier as one of the incremental approach to handle this particular problem in the effective way. And this is a source where you can able to see my ID6 and B. This is the kind of incremental version of decision tree induction algorithm. So I think if you want to do the theoretical research, that is a very good, you have lot of scope in terms of getting acceptance from reputed publishers. And my second contribution is focused more on developing the kind of naive classifier. Hope most of you are aware of the working principle or underlying mechanism of various naive classifier, which is based on the concept of conditional probabilities. So where we focus more on are the people trying to apply the kind of stuff that is called as statistical formula, otherwise it's called as the Bayesian theorem, or it's called as the Bayes theorem. Hope most of you are aware of the Bayes theorem. What is the various terminology offered by the Bayes theorem, and what is the prior probability, and what is the posterior probability, then what is the likelihood, and what is the hypothesis, so on so. So I assume that you are aware of you are very clear about the basic terminology that are applicable to any kind of Bayesian classifier. In that case, what I did as part of Bayesian classifier is when you see the history of the Bayesian classifier in the theoretical way, what is the problem in the Bayesian classifier is this particular classifier assume all the attribute or all the feature are independent of each other. I will repeat again. The Bayesian classifier always assume that the attribute or feature are independent of each other. But when you see the real world, it's very, very difficult because we are not supposed to say the feature are always independent of each other. So what is the major problem in this? In some cases, we can able to see there are the kind of dependency among the various attribute or various features. Say, for example, we are working on the weather prediction system where there are a lot of predictor that applicable to particular case. Say like temperature, humidities, windy. These are all the kind of predictive variable that related to the target. The target is play or not play, or rainy or no rainy or not rainy. Now the point is we can always say that there is a dependency between the two predictor, namely humidity and temperature, or namely temperature and other any kind of predictor or predictive attribute. But what is the major problem in the Bayesian classifier is always assume that all the attribute or the feature are always independent of each other. But that is the reason why the Bayesian classifier is also called as naive. So which means in the real world, we cannot able to see the independence between any kind of predictive attribute. That is one of the major problem as in the case of the Bayesian classifier. But what I did as part of my doctoral research in the Bayesian classifier is, what we are supposed to do in the Bayesian classifier is, we have to calculate both prior and posterior probability for the given data set. So later, we try to identify which data set or which data pattern having the higher probability, higher conditional probability. So we have to assign the class label for the particular data set based on the higher probabilities values. Now, there is a question. Assume that we are getting the equal value for the particular test set. I mean the equal probability value for the particular test set. Equal in the sense the 0.5 probability for the class 1 and also the 0.5 probability for the class 2. So this is said to be the kind of tie breaking. So what will happen in this particular case is the Bayesian classifier cannot able to make the kind of appropriate decision where we are getting the equal number of posterior probability for the two different test example. So what is happened in the Bayesian classifier is there is a kind of randomized assignment is done in most of the literature. When you see the most of the literature, they are using the kind of random assignment. So what I did as part of my course of study in the PhD is, so I handle the problem of tie breaking in Bayesian classifier. When we are getting the equal probability values, I have provided the kind of approach that is called as, I named as the kind of NB plus, that is called as incremental version of Bayesian classifier. That is what you are seeing in this example, right? This is where you see kind of NB plus, that is a kind of improved Bayesian algorithms. So where I applied different kind of statistical model to resolve the problem of tie breaking in the Bayesian classifier as well. And this is another problem that you are seeing as in the case of K nearest neighbor classifier, where there is a chance of majority voting failure. So it's always possible to develop the kind of mathematical model to resolve the kind of majority voting failure as in the case of Bayesian classifier. So what is the point here is you try to develop the kind of theoretical model to resolve the problem of posterior probability failure in Bayesian classifier, or to handle the problem of majority voting failure in both K-NN classifier, or as in the case of the K-mean clustering, you try to identify the appropriate value for the K. And again, in this example, I am interested to explain you about the kind of new area of research in the area of data analytics that is called as a behavior modeling. That is called as basically the behavior analytics in decision making. I think this is one of the most thrust area as in the case of the machine learning and data science research. The topic is called as behavioral analytics. So in this particular case example, I am really interested on make the kind of study on behavioral analytics study by applying the kind of machine learning and various data analytics stuff. So in this particular example, I am interested to make the study on identifying the behavioral analysis on the supervisor and research scholar relationship. So my analysis is based on the perspective of supervisor, not based on the perspective of scholar. And another case study where I interested to perform the kind of analysis on make the thorough study on consumer behavior analysis with the help of both data mining and machine learning stuff. And so this is the kind of in this particular example, I have performed both kind of primary as well as a secondary data analysis. And I have collected data from with the help of Google Form, and I have formulated and prepared my own Google Form and submitted to various participants around the global level. And some of the participants are from different countries and different areas. Say like I have collected the data responses from Rajamangala universities, which are located in Thailand, and some other participants from University of Oman, Muscat, and few respondents from Indian Institute of Technology, Madras, and few respondents from United States, and a few respondents from Periyar Manima Universities and Tyagaraja College of Engineering, Velamal College of Engineering and Technology, and SRM universities, KL universities, and VIT universities. So what I did is I have performed the kind of primary as well as the secondary data analysis in this particular applications. So I have formulated the variety of questionnaire. I think that is a really challenging task in this particular example is to how to formulate or how to develop the variety of questionnaires. So when you see this particular questionnaire, you can see that as a teacher, do you actively encourage your student to explore the new methodologies and new approaches that are particularly known or completely unknown to you, rather than your familiar approach? Are you direct your student to go along with their own interest, or you have to force them? That is the kind of survey question I give to both respondent of different universities. And this is another question as part of the survey where you can see that assume that you are from the department A and you are allocated a student for industrial project and who is pursuing the project that is not fully aligned to the department A, and the student may be interested to pursue the project with the faculty he belongs to the department B, and would you like to give your consent to give that particular project to another faculties? So what is observed that most of the 70% of the respondent are really interested to accept the proposal, and another 30% of the respondent, they really reject these particular proposals. And coming to the main point of this particular study, and where we can see the two different kind of behavioral analytics. The first kind of analytics is called as exploration and exploitation bias. I will repeat this again. The first kind of bias or analytics is called as exploration and exploitation bias. Say, for example, there are some teachers who are biased toward exploitation and preferring to what they are familiar with and what has worked for them in the past. And what is the problem associated with the student is student may find difficulty to explore the new area under their guidance if they are resistant to change. So this is the kind of exploration and exploitation bias. So what may happen in this particular bias is what will happen is the scholar may get the post from the faculties, and the faculty may force the scholar to, and they direct the scholar to continue their PhD on the particular area. I think that is a kind of irrationality as in the case of the behavior studies. And the second kind of bias is said to be endowment effect. That is a kind of endowment effect. So what is the idea behind this endowment effect is, say for example, assume that I am perceive something. What I'm supposed to do is I assume that what I perceived is really better than all other example in the world. Assume that I'm getting the kind of laptop or kind of any other systems. So what I assume that my laptop possesses very high capability than comparing with other kind of system. That is the kind of endowment effect I found as in the case of the second example, where there is a student who allocated for the faculty of department A. Later, what will happen is the particular student are really interested to continue his project on the department B. But what has happened is the faculty of the department A not provide his consent to continue this particular project with the department B. That is a kind of endowment effect. But I telling you that this endowment effect is again the kind of irrational behavior. That means it's not the kind of good behavior, right? So based on the previous two questions, so I found that there are a lot of endowment effect and lot of exploration and exploitation by art that I identified but among the various researchers in the academic institutions. And this is the third category of bias that I observed. Say, for assume that you are doing the research work using the approach one, and you find that the new approach have coming and gaining popularity, but the outcome are unknown. Now the point is, what will you be your actions? Whether you are going to continue with the approach one, or you just wind up the approach one and you go along with the approach two. That is the point. So what I observed is that there are 53.3% of the respondent are really interested to continue with the existing approach. I mean the approach one, and nearly 46.7% of the researcher, they're really interested to restart with the new approaches. And this is another point that I observed. Say, for example, while interviewing the particular scholar during the PhD presentations, you found that the interviewer does not perform well during the kind of interaction meeting, but he secured the kind of very good score during the written examinations. So now as a super, whether you are really interested to give your consent to the particular scholar or not, this is a kind of bias. So what we observed is that around 80% of the scholar are really not at all will really interested to provide the kind of acceptance in this particular case, and another 20% of the scholar are not really interested to provide any kind of acceptance to this particular case. And this is said to be the kind of bias that is called as horn effect. That is called as a kind of horn effect. Say, for example, I am assume that myself as a student and I am appearing for the PhD entrance examination as well as the kind of interaction meeting. So what is observed is that I am performing well in the interview. Not sorry, I am performing well during the kind of written test, and I am not perform well during the kind of interactions, which mean I raise a kind of argument with the panel of experts. So which may lead to the kind of bias that is called as the horn effect. So what will happen is, as a supervisor, you are right leading the panel where you found some of the student are make the kind of argument with you. The point is, or the question is that, are you really give your consent to take the particular scholar as your student or not? That is the kind of question. So that is comes under the category of bias that is called as a horn effect. And another kind of bias that also I noted while referring the kind of previous example, that is called as status quo bias. That is called as a status quo bias. So when we talk about the status quo bias, say for example, as a researcher with status quo bias may be more reluctant to consider the new approach, which become more popular and potential benefit. Say for example, assume that I am the kind of person I really always believe with the traditional approaches, but and I am also good in the traditional method, and also you assume that there are a lot of new innovations are coming. So assume that I am the kind of status quo person. What I'm supposed to do is I'm not at all interested to apply any kind of new approaches to my research. What I'm supposed to do is I'm always apply the kind of traditional method rather than new approaches. That is the kind of bias that is called as a status quo bias, which means I am only interested to apply or work with the traditional approaches rather than the new kind of stuff. And when you see the behavioral analytics, this status quo bias again is the kind of considered as a kind of irrational behavior. And this is another interesting question that I have done the kind of evaluations. Here you can see that when you work on the research with the scholar and you ended with both the significant and the kind of non-significant research. Now the question is, would you consider publishing or sharing the studies with only significant research or the studies with both the significant and as well as the kind of non-significant research? So what is observed based on this particular study is 73.3% of the respondents are really interested to disseminate both significant and non-significant research, and only 23.6% of the researchers are only interested to disseminate the kind of the significant research. But personally, I tell you, it is really important as a scholar, you try to disseminate both significant as well as the kind of non-significant research while you are submitting the kind of research paper to the leading journals. So that is a very, very essential. And say, for example, this kind of bias is said to be the kind of publication bias. So publication bias. So this is the something like, this is the kind of tendency of the researcher to publish the studies with only significant research to the leading journal by ignoring the kind of non-significant research. But again, it's a kind of irrational behavior, and it should be avoided as in the case of the quality publications, and it's a kind of ethical violation as well. And the last kind of bias is called as a sunk cost fallacy. I think is a kind of interesting part. That is something like, assume that if I spend already on the particular areas, so what I'm supposed to do, I continue based on that. Say, for example, I'm going to the hotel and the place a kind of order, and later I came to know that the food are not good in this particular hotel. But what I'm supposed to do is, what I'm supposed to do in most of the cases is, I'm not going to ignore it. I'm going to continue, and sometime I may eat it. So this is a kind of irrational behavior that is called as sunk cost fallacy. Similarly, I'm buying some items, right? So later I found that it's not fit or it's not good for me. What I'm supposed to do, instead of throwing it outside, I stick on with that particular product or item. That is a kind of sunk cost fallacy. That is another kind of irrational behavior. So what I observed is, this is a kind of, this is a he's my one of the research scholar. He provided a lot of support to perform in the data collection during my course of this particular studies. And another study that also interested on consumer behavior, that related to the frequency of buying product by the different kind of customer, say like tea, coffee, soft drink, and medicine, so on. So, and there are a lot of similar kind of survey are conducted in this particular example as well. And say for example, and you have gone to the particular buy a mobile phone at the particular uh, suddenly stopped particular working area and service, and you go for the new mobile, or whether you will do, or you will purchase a new mobile, or you stick on with the previous one. That is a kind of study that I did. So the point here is, so which is a very challenging part in this particular example, is that performing the kind of framing the questionnaire is always challenging, because I feel lot of problem during the question formulation. Even I did this kind of studies during my course of studies at IIM Tiruchirappalli. So while applying the kind of data analytics and machine learning algorithm are really easy in this particular example, but formulating the kind of questionnaire is really very, very challenging. So if anyone is kind of person, those who are really interested to on the data analytics stuff or data analytics algorithm, so you try to work in this particular area that is called as the behavior studies or behavioral analytics, where you try to collect the data from different consumer and different user, and where you try to formulate your own questionnaires and try to apply the various data analytics stuff. So there are lot of opportunity for this particular example, as in the case of the modes of the data science journal and publications. And what I observed based on this particular behavioral studies are, the number one is the kind of choice supportive bias that I identified. Say like, this is the kind of feel only the benefit and goodness about the choices, and always overlooking the flaws. Say for example, this is something like remembering the chosen option as being better than they actually were. That is a kind of bias that is called as the choice supportive bias. And the second kind of observation that I marked is gambler fallacy. Say for example, here what I'm supposed to do is, I make the kind of mistake believe that some people that independent even are interrelated. Say for example, I'm getting very good score in this particular period. What I'm supposed to do, I assume that I will definitely get the similar kind of score in the future. But the point is, both occurrence of the result are highly independent. But what I am assuming that there is a kind of dependency between the two variables. That is the point of assumption I am making. Again, is the kind of irrational behavior that should be avoided. So the point is, Hamler fallacy is not the kind of very good approach. That is why is referred as the kind of irrational behavior, as in the case of the cognitive studies. And the third bias is called as the Hodgkin fallacy. So where someone believes that first experience a series of success outcome in most of the cases, assume that they are always getting the continuous success in the future cases. That also the kind of irrational behavior. So finally, we also noted the kind of status quo bias in most of the cases, as in the case of the both consumer behavior study as well as the study on supervisor and the kind of student studies. So what is the future direction in this particular study for the new researcher or? So I request you, like you try to apply the kind of ML techniques in this particular behavioral analytics study. You apply the kind of classification algorithm. So where you collect the data from the different consumer and different people, and where you try to classify the people based on the various behavior. Say, for example, you try to classify the supervisor based on the various bias that observed. Say, like how the people are behave, as in the case of Sanka's fallacy, or as in the case of exploration bias, or as in the case of other kind of bias. So what is really required is you have to do the study on at least 5 to 10 different biases. You collect the data and you put the label for each data set, and you apply the various machine learning algorithm stuff on the data set. Then you try to classify the people. That is the kind of classification problem as in the case of behavior study. I think there are only the limited number of papers are available in this particular area where the different ML algorithm are applied on the data of consumer and or the data of supervisor and student. Again, I am telling you that there is a very kind of very good potential research area where you apply various kind of machine learning algorithm. So another area that you focus on is on you try to apply the kind of various unsupervised learning or the kind of clustering algorithm where you try to group the people having possess a similar kind of bias or similar kind of bias or irrational behavior. Say, for example, there are, assume that you are conducting the survey on around 1,000 to 10,000 supervisors, and you apply the various clustering algorithm like k-mean, k-mean hierarchical or so-and-so model or grid and so-and-so. And you try to group the people or you try to group the similar supervisor based on the various bias observed. That is a kind of very good future research direction in this particular area. And finally, I would like to talk about another major study that I contributed as in the case of applying the machine learning algorithm for the problem of employee attrition predictions. So when you see this particular study, I perform the kind of both primary as well as secondary data collections. So that means I have used the data, some kind of synthetic data that available in the one of the leading data repository like Hendrix, not is from I think is from the UCI machine learning repository, and I also done the kind of primary data analysis where I developed the kind of Google form and given to the various respondent throughout the entire various institutions across the global level, and I have collected the data and where I apply the various kind of machine learning algorithms, and I observe the various kind of stuff in that. And before going to start with particular sessions, I would like to highlight why I'm interested on this particular study. So this particular study is focused more on making the kind of prediction or classification of employee attrition in any given organizations. So hope most of you are aware that the employee attrition is the kind of major issues in many organizations. Say like we can see the kind of higher attrition rate in most of the industry, but nowadays not only in the industry, in academic institution as well as. So that is why I really interested to performing this kind of study on both academic institution as well as the kind of various IT industries as well. And to perform this particular study, I have collected the data from IBM, and so hope you most of you are aware of IBM is a very one of the international business companies, and having nearly 3 lakhs and 50,000 employees. They are working in the different vertical domains, and they are working in the different area, as in the case of the computer and IT domain, say like data analytics, and they are working on the various kind of vertical domains like cloud analytics, data science, and other hardware areas. And this is the point where you can see what are the various attrition rate that applicable to the various sectors. So it is observed that higher level of attrition was recorded in the retail industries, followed by the transport and logistic, and then the kind of consumer industries, and also in the kind of various IT industries. But I also found that the attrition rate is very high in most of the academic institution, particularly the most of the private institution rather than the government academic institution. That is why I thought of conducting the kind of primary study from the people those who are working in the various kind of private universities. This is the kind of why I am really interested to perform this particular kind of predictive study with the help of applying the various data analytics stuffs. And these are the questions that I am really interested to work on. The firstly, so I am interested to apply the kind of data mining and machine learning stuff to predict what is the attrition rate in the given organizations. And secondly, I'm interested to identify what are all the most important attributes of the future that affect or that may lead to the problem of turnover or attrition in any organizations. So here I mostly interested to identify the kind of what are all the most dominating attribute that may lead to the problem of attrition in any given organizations. And my research third question focus more on who will leave from the organization and why they will leave from any organization that I'm really interested to perform the kind of study. And my fourth research question is where I interested to ensure what is the attrition rate for the given organization and what is the level of attrition rate, whether it's high or kind of low. And fifth question, I really interested to ensure what are the factors that affecting attritions. So in this particular example, I applied the different kind of attribute selection or feature engineering model. So based on that, I found what are all the most influencing attribute that may lead to the problem of attrition in the given organization. Finally, I'm also interested to provide the kind of recommendation to the different industry or most of the managerial organization. And this is my kind of general and specific objective for these particular problems. So, but predominantly, I am mostly interested to identify what are all the various causes for employee attrition in the given organizations. And I also, before going to apply the machine learning algorithms, I very clearly formulated my kind of hypothesis approach, where I apply the kind of both null and the kind of alternate hypothesis. And when you see this particular hypothesis testing, so I have formulated two different hypotheses, and where I consider the two different kind of predictive attribute. Say, for example, when you see the null hypothesis, I just compared both job satisfaction and attritions. So what I say in the null hypothesis is that I assume that there is no significant relationship between job satisfaction and attritions. As in the case of the alternate hypothesis, I assume that there is always a kind of significant relationship between the job satisfaction and attrition. And for my second comparisons, I consider the two different predictive variables, namely overtime and attritions, where my null hypothesis says that both overtime and attrition are independent of each other. They are not at all related. But as in the case of alternate hypothesis, I assume that overtime and attrition are highly related, right? Both are highly related with each other. And finally, I just compare the gender and attritions. My null hypothesis says there is no significant relationship between these two, and alternate says there is the kind of significant relationship between the gender and attrition. That means if I am kind of male, there is a chance of higher attrition. If I am the kind of female, there is a chance of attrition is very low. That is the kind of alternate hypothesis I formulated. If anyone, you are doing the kind of attrition prediction method where you apply the data mining or machine learning algorithm, this is not the kind of various hypothetical method. You can formulate your own approach where you try to identify different kind of variable and you have to formulate the kind of null and alternate hypothesis. That is your wish. But the point is, I am applying the kind of various predictive attribute in this case. And so coming to the major part of the presentation is, when you see the data set is consists of around 1430 700 record, and it consists of 35 attribute, and is a kind of binary classification problem where there are two kind of classification. One is whether the employees leave from the organization or whether the employee did not leave, or having the chance of attrition or no attritions. And this is the kind of predictor and various predictor variable that offer in the particular data set, like age or business rate or education, educational field or gender types or job level or job role, job satisfaction, and overtimes if they are working overtime, and kind of work-life balance, and you can see various other kind of approaches. In this particular example here, you can see what are the various kind of machine learning workflow that I applied. Firstly, I perform the data collection. This is the kind of secondary data analysis. Why secondary data means I collected the data from IBM data repository that is available in the Gaggle, and most of the data is a kind of synthetic. It's not the kind of primary data. That is the point I would like to highlight. So whatever the data I collected is the kind of synthetic data. So the machine learning task I applied are data cleaning, and I applied the kind of attribute selection method, and later I applied the model selections where I applied a variety of machine learning algorithm like decision tree, KNN support mixin K, nearest neighbor, and finally I applied the kind of Bayesian algorithm as well. Then I tested the model by supplying the kind of test record where I applied the different approaches. But I am mostly interested on the kind of cross-validation method rather than applying the test method as a evaluation, because there are a lot of stuff and opportunities are available while we working with the cross-validation as a test method. And model are evaluated using various measures like accuracy, precision, recall, F1 measure, and I also applied AUC curve, because when you see this particular data, the data is a kind of imbalanced data, which means where you can see the very less number of positive example and higher number of negative examples. This is said to be the kind of class imbalance problem, where what will happen is if you apply the kind of machine learning algorithm where the data possesses the problem of class imbalance, automatically the performance of the data mining or machine learning algorithm is get degraded. So what is really required in that case is, before going to apply the algorithm, you have to perform some sort of data cleaning approach where you try to make the balance between the both positive and negative example. So what I found is this particular data is possess the problem of class imbalance. So that is why I applied the kind of data pre-processing method before going to apply the variety of machine learning algorithm in this particular example. Finally, the model are deployed, and since the data is possess the problem of class imbalance, I applied another kind of statistical approach that is called as AUC. So most of you are aware of this particular measure. Most of the guys are really interested to see what is the accuracy, what is the precision, recall, and F1 score. But if you are doing the kind of research where you see the kind of class imbalance problem, there is another good measure is available in the machine learning that is called as AUC score. So better you have to calculate the value of AUC if suppose if your data possesses the problem of class imbalance. This is the kind of result I derived with the help of Python Anaconda framework. And this is what I observed, that is that there is a kind of what I observed is there is a kind of significant relationship between the job satisfaction and attrition. What I observed is job satisfaction is one of the kind of major player as in the case of detecting the attritions. And I also observed that there is no significant relationship between the overtime and attrition. Overtime is one of the major dominating factor as in the case of leading the problem of attritions, and there is no impact on attrition, gender versus attrition, that I found with the help of this kind of hypothesis testing. And these are various results that I derived with the help of applying various Python stuff, and this is the result I derived, where you can see I can receive the very higher value of true positive rate for the gradient boosting, and the kind of true negative rate for the random forest algorithm, and I achieved the accuracy of 86.62 for ADA-boost algorithm, where ADA-boost and random forest and gradient boosting are the kind of ensemble algorithms. So now here you can see that sometimes we are often getting confusion which attribute or which measure is obviously important for this particular case. But I believe that true positive rate is very, very essential, because in the true positive rate only we are really interested to ensure that whether the employee having the problem of attrition or perfectly classified as attrition. But as in the case of the true negative, we are only interested on the person or employee not having attrition or really classified as not having. So what I observed that in this particular example, the true positive rate and true negative rate are going to play a major role. So, but what is the new research direction in this particular example is that, so when you see the accuracy of this particular classifier, the accuracy is very, very minimal. Why the accuracy is very, very minimal is, when you see that this particular data set, the variable are always dynamic, which means always is very difficult to ensure what are the factor are really going to cause the attribute for any given employee. Say for example, when you ask me today, what are the leading factor for causing attrition, I may tell maybe I may tell the salary is a major criteria. But when you raise the same question by tomorrow or day after, I may give the different kind of answer. So expectation or not kind of statistical variable is a kind of dynamic, is always ever changing variable. That is why it's very, very difficult to predict the kind of employee attrition with the help of machine learning algorithm. So what I am trying to say here is, if you are really good in theoretical machine learning research, when you see or while you apply the kind of the traditional machine learning algorithm, the accuracy is not up to the expected level. So what is required is you try to develop your own machine learning algorithm where you try to get the very good kind of accuracies that are better than all the kind of conventional machine learning algorithm. I think that is a lot of potential research opportunities is available in this particular example. And this is another case study that I performed with Indian academic institution. These are all the factors that I consider. My first factor is about career or career planning related factor, and the second factor related to work environment related factor, and remunerations, other benefit offered, and management related factor, and the kind of work life related factor. Finally, the personal life related factor. These are all the attributes that I focus. And here I perform the kind of primary data analysis where I collected the data by formulating the Google form and submitted to the various stakeholder. And these are the various my main factor and classification I have done, namely the career or career planning related factor and work environment related factor. And finally, that is the kind of remuneration and benefit related factor that I really interested. And so this is a kind of finding that I observed while performing the various kind of data analytics stuff. And I found that the major contributing factor which may lead to the problem of attrition in many academic institutions, particularly the private engineering institution or any organization or career planning, it is observed that 50% people give respondent for the career planning, and another 43.3% mentioned as appraisal system, and only 8.7% of respondent are quoted the health problem, and another 34.6 responded or consider the work-life balance, and 19.2% are mentioned about job profile not meeting their expectations, and another 35.6% of the respondent are not at all satisfied by the remuneration and other benefit offered by the given organizations. And when I did the survey with reference to the career and career planning related factor, 27.7% mentioned about lack of responsibility and ownership, and another 50 are talk about lack of employee motivations, and 66, that is a higher, I think, actually, lack of promotion opportunities and kind of career guidance advancement, and only 29.1% respondent mentioned about lack of opportunity for training and kind of development, and Finally, another 23.3% mention about lack of opportunities and various challenges for in the organizations. And when you see this particular graph, you found that 54.8% mentioned about work pressure and the kind of long working hours. And next dominating factor we found is a stressful job requirement. And another most dominating factor is more workload and impractical target assigned by the management. And very less dominating factor are uneasy relationship with the various peer group or colleagues. And another less contributing factor that I observed are boring, de-skilled work and the kind of monotonous. And this is a kind of remuneration and other benefit related factor that I identified. So major leading factor is salary and the kind of financial contribution by the management. And another one of the most dominating factors that I observed is absence of the transparency in various appraisal system offered by the institution. And another 33% mention about less or non-financial benefit or other kind of perk. And only the 28% are mentioned about unbenefit or low quality resource available in the organizations. So what I'm requesting you, so you have to conduct the kind of similar survey where you collect the data from the vertical domain, where you collect the data from the different people working in the different academic organization, not only in India and abroad. But this particular study, I collected the data only from the professor, those who are working in Indian academic institution, mostly the private organization. But if you are really interested in this particular study, you try to collect the data in the vertical way, where you try to collect the data from different people, including international universities, where you apply the different data science stuff. And this is the other kind of observation that I noted and as part of this particular study. And the main advantage of this particular study over the study with IBM is, in this particular example, I collected the data in the real time, but previous study, I collected data from the Gaggle. And another major problem is the data is the kind of synthetic. Why I'm telling this particular point is, if you work in the particular area where you submit your paper to the reputed international journal, what is expected from the journal publisher is you should perform the kind of primary data analysis rather than the secondary, where you try to collect the data in the real time. If you apply the kind of machine learning algorithm only on the synthetic data, obviously getting acceptance from the particular journal is always very, very difficult task. So I'm giving the personal recommendation to you is that you have to perform the kind of primary data analysis if you want to do this kind of particular study. That is very, very essential. And when you compare what are the various problems that associated while performing the employee attrition for both academia and industry, so there are three major factors dominating in IBM. Not only IBM, most of the industries are monetary benefit. That is one of the dominating factor, followed by the personal relationship with peer groups, and finally the employment. But the same factor are varying for academic institution. One of the most dominating factor, as in the case of academic institution, is career or career planning, followed by the work environment. And the third factor is various benefit offered to the employees. And finally, the management related factor is a fourth dominating factor. Finally, work life related factor and the kind of personal life related factor. This is what the kind of observation I made. So we can see the different kind of expectation from both academia as well as industry, as in the case of employee attrition. And this is the questionnaire that I formulated, say like what contribute to the Indian academic institutions. And second question, I talk about, say like for the question where you can see what are the salary or options of transparency or low or less financial, so on so. And this is the final question. Please select all the personal life related factor that cause the kind of attrition in the below listed options. No personal life, friend moving out or marriage or getting married, health or physical alignment, decision to pursue higher studies or relocating the relocation. Again, what is the major problem in this particular study is formulating the questionnaires. That is very, very tough, I think. So you have to focus more on this particular area, how to formulate the kind of questionnaires or how to identify the kind of most dominating variable. That is really challenging. So even I spend a lot of time to work in this particular area. Firstly, how to ensure that what are the variables that may lead to the problem of attrition in both organization, and secondly, how to formulate the various questionnaire as in the case of various cases. But applying the machine learning algorithm is not the kind of complex task that I feel. So coming to the conclusion that kind of I would like to hear in this example, I would like to give the kind of comparison between what is the technology versus the reality, as in the case of the COVID-19. And we all know that the fighting against the COVID-19 has been the kind of very expensive. And what we found is, say, for example, identifying what are the variable that may lead to or that may influence the spread of this particular virus. I think there is no surveys at all available in COVID-19 research, which will give you the clear idea about what are all the various influencing variable or influencing factor, as in the case of the spread of any kind of COVID disease. And there are a lot of challenges that also we face, say like whether the healthcare technology alone is really capable to provide the kind of solution to this particular case. And say for example, the people are talk about the two different kind of system during the COVID-19 pandemic. Even along with one of my scholar and myself, we developed the kind of deep learning algorithms where we consider the various image of COVID-19 and where we apply the various deep learning model, and we analyze the performance of how well the performance of the different deep learning algorithm are varying with reference to analyzing the different kind of deep learning algorithm or the model. And there are two approaches basically applied in the COVID-19 research. The first type is called as healthcare research, that we focus more on how to apply the different healthcare approaches to the given problem. But another area that is booming nowadays is called as kind of research that is called as human care research. We most of you are aware of what is the healthcare research. When you see the healthcare research, which is mostly focused on the kind of how to provide a kind of diagnosis to the given problem, or how to make the prediction with the help of the available machine learning stuff or the machine learning algorithm. But when you see the human care, which focus more on how to prevent the disease, but healthcare is focused more on how to diagnose the kind of disease. But the human care is not focused on making the kind of diagnosis on the disease, but is focused more on how to prevent the disease, because we know prevention is better than cure. And also this human care focus more on how to formulate the kind of lifestyle strategies and how to provide the kind of diet recommendations to the patient, as in the case of COVID-19. So what is really required if you want to develop the kind of very good strategical approach for healthcare and human care for COVID-19 is you try to combine both the kind of healthcare and human care approach. That is really very, very essential. And again, there are a lot of challenges that notified in image processing technique while applying to the COVID-19. And there are a lot of diagnosis approach that are also available. And again, this is very difficult to identify the kind of asymptomatic COVID-19 cases. That I say, as in the case of the machine learning, it's very difficult to control the kind of false alarm rate. Say like where the patient having the problem of COVID-19 may be classified as not having COVID-19 by the particular machine learning algorithm, that may lead to a lot of problem. So where both controlling the false alarm rate is very, very difficult task, I think. And again, the increase of more interdisciplinary and the kind of gross interdisciplinary research that is very, very essential, as in the case of COVID-19, and more focus may be given in the area of device design. I think that is one of the most thrust area, where it is expected that the people working on in the area of AI, machine learning and data science, they work along with the people working in the area of medical device industry. That is very, very another essential areas. And I always believe that the research outputs would be connected with the societies And that is why you try to apply various kind of data analytics or ML algorithm on the real world applications. Say like data from the healthcare or finance, market or entertainments or national security as well. And finally, the hard work is an investment and not the kind of expense. So these are the potential area where AI and machine learning are established a kind of dominations. The firstly, the fintech, that is a kind of financial derivative where the people try to apply the various machine learning algorithms on the financial data. The second major area is a kind of agri-tech where the various kind of ML or deep learning algorithms are applied on the agricultural data. Even previously, I contributed something in this particular area by receiving the grant from ICSS. For the fintech, I worked with the kind of AML algorithms to identify what are all the issues that are associated with the financial fraud, and if you achieve the kind of credit card to the various customers. And coming to the final area of my discussions, now the people are talking about another area in the AI that is called as responsible artificial intelligence. So we will talk more about four different capabilities that is called as transparency, rules, regulation, governance, fairness, privacy, and the securities. Say like if you are working with any kind of AI system and you are going to deploy any kind of AI system to the various stakeholder of the customer, you who will responsible for ensure whether your AI system are really not violating any kind of ethical clearance or any whether is really capable or whether they are not violate any kind of legal consequences or whether it may cause any kind of legal consequences or whether your system are really transferable or whether what kind of privacy and security mechanism that you are inbuilt with your system. There are a lot of question comes. So that is the people are talk about responsible artificial intelligence. But when you see the countries like India, there is no specific framework are available, but government formulated kind of very good framework about what are the strategies or what are the strategical framework that apply to any kind of AI system development. Even I very clear to you mentioned that there is a framework that formulated by the government by December 2023 as part of the one of the leading event that held in Delhi, I think. So where they formulated what are the various rules, regulation, and ethical responsibility that applicable for any kind of AI application. That is called as the kind of responsible artificial intelligence, or simply what are the things are expected from the developer of any artificial intelligence systems. Why this is really important? Say like as in the case of when you apply the any kind of AML model on the real data, what is happening in the most of the developed countries like US is where in this specific example you can see where the ML algorithm are applied on the kind of image data set. So what will happen is the algorithm are not able to identify or the algorithm just ignore the image of the black people is only able to perform the kind of data analytics or machine learning stuff on only the image of the color people. That is the kind of problem that happened in US in the year 2017. So what happened is, so the particular algorithm or eliminated the particular target, not target variable, the predictor variable that is called the color of the particular persons. Now the question comes, who is responsible for this particular problem? Whether the developer of the algorithm or the training data that collected by the user or the government of the particular organization or particular organization or countries. There are a lot of questions are arising. That is a kind of variable bias in artificial intelligence. So what happened is the algorithm or try to ignore some variable and they are only capable to consider some kind of variable. That is called the kind of variable bias as in the case of artificial intelligence. So here you can see another examples where what happened is the normal people are classified as a kind of terrorist by the various machine learning algorithm. So again, is may lead to the problem of lot of consequences in US, where the kind of normal guys are classified as abnormal and kind of abnormal are classified as normal. So this is mostly due to the nature of algorithm that used for the experimentation. This is the kind of what happened is it's seen the kind of very higher rate of true positive rate. True positive rate is very less in this particular case. So something like all the positives are classified as negative. So what is really required is this has happened only due to the fundamental underlying principle of algorithms. So sometimes what happened is if there is a problem in the associated algorithm, automatically the result is also get affected. Now the question is comes whether it's only due to the algorithm that we use for the experimentation or is the problem is created by the developer. There are a lot of questions are happened as in the case of artificial intelligence. Again, AI is again dominating in the many industries. Even most of the IT company, they fire woman employee rather than the men, where they applying the different ML stuff, where they try to ignore the attribute which talk about the gender as female. They straightforward, they try to remove those kind of attribute. They are only consider the attribute where the gender as men. So this kind of bias are happen in while applying various machine learning algorithms. They are considering the particular predictor variable and algorithm obviously eliminate other kind of predictor. That should be considered very seriously if you are the kind of very good machine learning researcher or developer. You focus more on this particular area as well. And again, if you are the kind of researcher, those who are working in AI or data science, and you also focus more on what the training algorithm that you are used for the experimentation, because sometimes there is a chance of bias due to the data set that you use for the experimentations, or sometimes the bias may caused by the kind of predictor or predictive variable that you are using for the experimentations. So even as in the case of the loan application, what happened is any predictor variable which talk about the color of the people that are considered the same loan application, the person having the color as block are eliminated by the particular algorithm. So you are very clear about whether your algorithm are really capable to consider all different kind of predictive attribute or the predictor variable that you are considered as part of the experimentation. Otherwise, you may face the kind of very serious consequences when you apply the AI algorithm to any real world applications. Again, there are a lot of limitations that also observed. Say the people are make use of the AI, as in the case of autonomous vehicle, there are a lot of problem are already noted while using the kind of driverless vehicle where we are using the AI technologies. There are a lot of trouble or a lot of things. And coming to the conclusions, so when you just see about artificial intelligence and machine learning and kind of data deep learning and the data science, where we can see obviously see the kind of overlapping between the four different terminologies, but we cannot say both are interchangeably used. Even when I started my PhD in the year 2003, virtually everyone was used the MATLAB as a tool for metric stuff, because the MATLAB came up with a very nice set of visualizations and the kind of file parsing. But all of them suddenly changed after the year 2006, because most of the publicly funded organizations are really interested on the kind of applied research where they think about replacing the MATLAB by the kind of other data mining or conventional stuff. That is why after the year 2006, the Java is dominated in entire IT industries. Vega was introduced. Even when I worked in Tyagaraja Engineering College, we formulate our own laboratory practice with the help of where we use the Vega as one of the visual learning and data analytics tool. But all of them suddenly changed after the 2006, because the big data was evolved in the IT industries, and the current conventional data analytics tool are not really capable to store the kind of big data, because the conventional data analytics are only talk about the terabyte of data. So after 2010, the data are generated from the various media or from the various sources like social media, sensors, so on. So that is why another technology was evolved, say like 2000, after 2006, Hadoop was introduced as one of the framework for dealing with the big data, but all of them suddenly changed after the year 2004. The R was introduced in the IT industry as one of the dominating tool for data science research, but all of them changed suddenly after the year 2006, where the Python displacing R as one of the dominating language for the data science research. But when you compare with the R and Python as a choice of data science or machine learning research, what is the major problem associated with the R is whenever you want to deploy your product to the customer or end user, you need to install the R tool on the client machine. That is not case in the Pythons. So Python is provide the kind of stuff if you want to do the any kind of machine learning or data mining or even data science research. I strongly recommend to work with Python rather than R programming or any other Vega or Orange or Rabbit Miner or so on. So because automation is very clearly possible if you apply the Python for any data science research. And say for another, say for example, if you feel that your data size is very small, is need not really required, it does not need you apply the kind of R or Python or Orange or so on. So if you have the data in the form of image or in the form of text or in the form of audio, video, you may apply the kind of deep learning stuff, particularly GAN or generative artificial neural network. You may expect the very good kind of uh, uh, output and result. And finally, we know the AI is not kind of new technology, but is rapid adaptation has come surprise to many areas. And nowadays, AI model and tool are part of our lives, and we are increasing our of what they do. And it is impossible to reverse AI intervention in the near future. But we will also continue to live our lives with a different technological aspect, and we also need to create a safe way to harness technology benefit and encourage the various future innovation that is offered by the various data analytics and machine learning approach. So finally, I put request to all the researchers, you focus on more theoretical and the kind of applications of applying the AI, ML, and deep learning on different areas. And this is the point from my end. And now I'm request audience to ask the kind of questions that related to the particular sessions. And finally, I would like to extend my thanks to the organizer of this 6 days international event, Dr. Magesh sir, and a professor and head of software engineering department. And also, I would like to extend my thanks to the coordinator and Professor Anuza and Professor Saranya from the Department of Software Engineering. And finally, I would like to extend the thanks to the most respected registrar of this prestigious institution and Vice Chancellor of this institution and the head of the Department of CSC, Dr. Pungulali Madam, for providing me an opportunities to interact with you. Thanks for the opportunity. Now, any question, I'm really interested to interact with you.
Excuse me, sir. Hello? Can you hear me? Hello?
Yes, ma'am. Audible, ma'am.
Hello?
Hello, ma'am.
Sir, yeah, I have clarification on.
Hello, sir. Hello. I have one clarification
Ma'am,
regarding
speak
your
a
research.
little bit loudly, madam.
No.
I'm not getting it fully. I'm not getting it, I think. Anuza, madam, I'm not getting it. Otherwise, you put it in the chat, sir. I'm really interested to respond in touch. Can you post your question in the chat? Hope some of the audience in this particular sessions are not like much about coding. For you, there is a framework is available. Even I thought of covering those framework as part of these presentations. That is called as teachable machines. So if you kind of person, those who are not really like the kind of serious coding, so there is a framework is called as teachable machine, where there is a dedicated framework is available, where we can able to apply the different images and various audio and video data as an input, and the machine learning algorithm, not machine learning algorithm, the deep learning algorithm make the kind of learning on those data and will make kind of predictions. Assume that you are working in the agriculture, you are in the agriculture area where you collect the kind of normal and leaf image, disease and normal image, and you just open your camera in the laptop where you try to capture both normal and leaf image and store the normal and leaf image in your desktop. Now you just click on the particular interface and where you load both normal and disease image as an input to this particular teachable machine. And the algorithm performs a lot of iteration. I think they are using the kind of GAN algorithm because the image quality sometimes is not up to the expected level. Sometimes you may collect the image in the night or morning, the capabilities are not good actually. So what happened is the algorithm do a lot of iterations or various iterations are executed by the deep learning algorithm, and it can make the kind of classification or prediction as the image is normal or abnormal. If time permit, I will take another 5 minutes to explain about this particular one. Otherwise, you just note down this. This is a teachable machine. You just download, go to the Google and just open it, teachable machine, and it will ask you to upload data which will in the form of images or audio or text, so on. So either you download, collect the data primarily and put it in your folder and do the kind of analysis. So coming to the first question, the question is about I'm coming to the first question. How do you measure the attrition factor and how did you the sample size for giving the decisions? I think there is no framework available to fix what are all the factors that contributing to the attritions. But the point is you have to perform the kind of literature where you try to download the data from various sources and try to ensure that what are all the various factors considered by the different people. That is the kind of attributes collections. And other side, you try to develop the kind of new attribute based on your capability, research capability. Even when you see my particular research, I applied both methods. Some cases, I collected the data from the previous literature and few attribute that I formulated the new, that is not collected from the previous literature. So my point for you is, if you want to do the kind of research in the particular attritions, you have to perform, you have to collect the data from the previous literature, I mean the attribute, and also you try to formulate your own attribute as well, so that getting acceptance or publication in the journal is very easy. And coming to the second question, how do you fix the sample size for the given decision? And in this particular, in my example, I have collected the data from 500 different participants. But what is expected is at least 300 is really expected. Otherwise, if you having the sample below 30, that may violate the principle of central limit theorems, which says if you apply the any kind of data science or ML stuff you should have the kind of at least 30 record is really required. So my suggestion is that at least you try to collect 300 or above that. That is really essential for this particular case. And coming to the next question, how do you frame the hypothesis? So how I formulated this hypothesis is, so after identifying what are all the variable or what are the predictive variable for this particular attrition costing, so I applied the kind of ADA boost and gradient boosting algorithm on all the predictive variable that I applied. And then I ranked all the predictive attributes according to the ranking criteria. And where I found that there are some attributes are really secured the higher rank comparing with other lower rank. So what I observed is that those attributes secure the higher rank are considered to perform the kind of hypothesis analysis. But the point is, I have not performed the hypothetical analysis in a random way. So this is the kind of attribute selection method I applied, where I ranked different feature with help of the various single and ensemble model. Based on that, I found what are all the highly dominating attribute, and those kind of attribute are only considered while formulating the kind of hypothesis in my example. But this is not kind of randomized selections. But I give the same kind of recommendation to all of you. So the point is, assume that you collected what are all the variable related to the attritions. Then later you apply the various attribute selection stuff, and you identify the what are all the dominating of the attribute. From the collection of dominating attribute, you have to pick any kind of best attribute where you formulate both kind of null and alternate hypothesis for your case. This is my point. And another question is related to, please provide your advice about necessary learning program to work with AI about pure IT related subject. So previously I mentioned very clearly that if you are the kind of person, those who are really interested to analyze the performance of the different ML and data science approaches, I think you may make use of the Vega. Is the very popular tool in most of the academic organizations. Even previously, I told IIT Bangalore, not now, 2006, they also use Vega as a tool for data mining laboratory and data mining applications. If you are not like kind of coding, Vega is a kind of very good tool. Even during my course of BSc, I use Vega to evaluate the performance of various data mining algorithms. And I also use Orange and R, but the major problem is automations is a major problem in both Orange and Vega. And if you want to develop the kind of product, or if you are working in the industry where you want to develop the kind of product for the or customer, where Python is a best choice, where automation is really possible. And when you see the most of the industry, data science industry, they are using Python as a programming language of choice for data science research. And in my case, I am using Anaconda, where I am using Jupyter Notebook to evaluate the performance of most of the model. But if you want to do a new kind of research, you focus on the behavioral analytics. I think there are a lot of scope in this particular area. I mean, there are only minimal number of research are contributed in the area of behavioral analytics that comes under the category of behavioral analytics in decision making, where you have to collect the behavior of the different consumer or user and apply the various ML stuff. And as in the case of the attritions, what is the challenge is achieving the higher accuracy is always very challenging. So what I am putting request to you is to develop new ML algorithm which may receive the better result than conventional method. Then it's really good. Because in this attribution, what is the problem is most of the attributes are dynamic, or predicting the cause of attrition for the human or any person is very difficult, because most of the attribute involve the contribution of the human being again is very, very difficult. Even I am also contributing in that way, where I focus more on developing the kind of very appropriate and very performing machine learning model to get the higher level of accuracy in the attrition data set. Because I applied this ML algorithm on many vertical domain, but most of the time I received the accuracy of more than 70 or 80. But unfortunately, when applied the same algorithm on the attrition data, the accuracy is maximum of 40 only. So the reason is this kind of attribute related to the attrition are very kind of dynamic attributes. So you try to develop the kind of very straightforward and strategical data mining or machine learning model, then really is good actually. What I am trying to say is you develop a kind of theoretical machine learning algorithm that may provide the better result as in the case of attrition prediction, then it's really good for you. Even this paper I published, one of the leading conference held in Indian Institute of Management, Nagpur, that I presented and published during December 2023. Any other questions? And if time permit, you work with teachable machine. That is really like your no kind of knowledge on the coding. I think it's a very difficult question. How to publish in the IEEE actually? Even I published two paper in IEEE. One is IEEE Transactional Engineering Management and another is IEEE Assess. I think among two, IEEE Transactional Engineering Management is very popular journal by IEEE publisher. And mostly they focus more on novelty of the work. And I found they are not encouraging the kind of theoretic application research. They are encouraging the most of theoretical research. But this particular IEEE publication, what I contributed is I consider the problem of software selections where I applied the different kind of optimization algorithm. Hope most of you are aware of the various kind of optimization algorithm are available, namely AHP and TOFSIS. That is a analytical and hierarchical processing. And another kind of optimization algorithm is a TOFSIS. Even on IIT Roorkee, I worked with this particular algorithm. I made the two different kind of contributions. The first contribution, I applied the various kind of optimization problem. And the second contribution, I focus more on developing the new kind of machine learning algorithms. So what I contributed as part of this IEEE transaction is I consider the software selection as a problem. When you see the software selection as a major problem, there are various choices that related to the software selection. Say, for example, some of you may interested on the reliability of the software. Some other may interested on the cost of the software. Some may interested on what kind of securities or privacy this particular software are offering. And some of you interested on this particular software are reliable. And some of you interested on other factors. So among available factor, how do you identify the kind of rational factor which may going to dominate whether to buy this particular software or not? For which I have developed a kind of new computational intelligent algorithms. And I also proved that these algorithms are capable than both traditional algorithms like AHP and TOFSIS. And I have collected the data from various software selections, both primary and I also did the kind of secondary data analysis. And I also proved mathematically about how well the performance of my model. I not only implemented with the help of Python, and I also worked the problem in the mathematical way, which means I have formulated my own mathematical framework for my improved algorithm. And I have collected the data from the primary and secondary, and where I compared various different conventional AHP and TOPSIS algorithm along with my proposed model. And I compared and provided very good detailed result and so on. So, but when you see the IEEE publication, it will take maximum of 2 years. Within 6 months, you are getting the kind of corrections, and later you will get second correction, and after 6 months, you will get third correction, and finally you will get published within the 2 years. So maximum time duration is 2 years. But if you want to publish a kind of paper in the IEEE, you better try to implement the theoretical research rather than the application. You have more chances. But there is another journal is available in the IEEE. that related to the earth science and AIML, where you have to apply the ML on the agriculture or earth science data, wherein there are a lot of opportunity for application research. But this particular journal like engineering management, you have to consider the performance of the conventional algorithm and develop a new algorithm and collect the data related to the engineering domain or the management domain. Then you have a lot of scope for getting published easily. That is the point. Any questions? So another question, how do you find the research gap and how to find the research gap, how to arrive on the idea actually? I think it's a very straightforward answer. We have to do the kind of very good data literature review. That is very essential, I think. Do very serious and rigorous literature review. That is a way to uh, fulfill what are all the gap in the existing method. What are the problems? Any questions? But major problem that I noted is data collection is always challenging because sometimes participants are not at all interested to give their input for right. Data selection is always challenging. And moreover, you have some knowledge on the statistical machine learning that also help you. Say like regressions or linear regressions or multiple linear regressions. Most of the agriculture data they are using linear regressions, where they consider various agriculture data as a predictor and target they assign as yield or no yield or chance of crop yield or no yield. That is considered as a kind of target variable, and all other factor like temperature, humidities and soil and all other factor are considered as a kind of predictor. And the people are applying the various linear regressions where they connect the crop yield with various kind of predictive attribute, and they can formulate the model, and model will help you make the kind of recommendation in the agriculture sectors. So they are using the kind of linear regressions mostly, and they are using the kind of deep learning algorithm, particularly GANs, because the image is very sensitive, as in the case of agriculture. Any questions? If there is no specific question, I request Anuja madam to conclude this particular sessions. I kindly request Dr. Anuja ma'am to conclude this particular session. Otherwise, any coordinator, I kindly put request. If there is no specific question, we can end these sessions. So finally, I would like to extend my thanks to the organizer of this event, Dr. Professor and Head of Software Engineering, and the coordinator, Professor Anuja and Saranya. But not least, I would like to extend the thanks to all the participants from different part of countries. And I hope you all really enjoyed my sessions. If you have any kind of doubt or any clarifications, email me at datascienceball@pme.edu. And also, if you want to work with me or with any innovative project, or we are new in this particular area and you are really interested to looking for any kind of innovative or join research in the case of AI, machine learning and data mining, data science and deep learning, I am really interested to participate with you. Thanks a lot, and we can end now. Thank you, ma'am.